Well, hello everyone. We are going to be doing our chemical reactions lab here, but in this video, 4 different steps showing a wide variety of different labs. So watch, write down your observations as they go through, and also be sure to answer the post-lab questions at the end of this activity. Let's jump into the first one. First up, we're going to be looking at sodium bicarbonate or acetic acid, otherwise known as vinegar and baking soda, something that you guys might have done before. Now, I'm going to show you guys the original, what it looks like before the chemical reaction, and then I'll show you what's happening as the chemical reaction is in place. Please keep in mind to write down your observations, and also keep in mind that some of these reactions will show more than one type of sign of a chemical reaction. So let's take a look at everything. So first up, we have our vinegar. Inside of the vinegar, notice that it's just a white clear surface. Use it for cleaning, using for cooking purposes, for different things like that. We also have our baking soda, our sodium bicarbonate. Let's go ahead and see what happens as we mix both of the chemicals into each other. And let me make sure that I have a good light here. So what I'll do, there we go. Let's go ahead and pour the baking soda into the vinegar and see what happens. Notice the bubbling, possibly. Do you hear anything? Do you think you would smell anything? What signs did you just witness? All right, y'all, let's move on to number 2. Alrighty, step number 2, part number 2. We are going to be mixing barium hydroxide with ammonium chloride. Here are the bottles for both, and notice that the bottle is on for each of them because there's something called hydroscopic, and this one here is a much, much larger bottle of ammonium chloride. The reason why they're hyperscopic is if they're left out for too long of a period, it will start to absorb the water that's in the atmosphere, and it will mean that the reaction won't go through as well. Now, I've already went through and used this thing here called a scoopla. Fun word. I don't know who thought about that. And I poured it here into these 2 cups. This one here is the barium hydroxide, and this one here is the ammonium chloride. Keep in mind that on your sheet, there's going to be something for the initial temperature of the starting materials and the final temperature of the products. Also keep in mind that this one here will have 2 signs of a chemical reaction, which we will talk about as we go through. One of them I will give you right away, as we have something here called a temperature probe. Now, it might be a little bit hard to see on the, there we go. On the webcam, you'll be able to see the starting temperature of the room. And we are going to assume that because the chemicals are in the room, that they also have a starting temperature of 25.5. So where you see it on your worksheet on OneNote where it says starting temperature, be sure that you're putting down 25.5. So let me go and grab the webcam, show you what all is going to be happening. I have the barium hydroxide here, kind of hard to see inside. There we go. And we have our ammonium chloride here, and I'm going to pour them in. I'm going to put the webcam back on my computer. Look, there we are. We're going to put it back on the computer. I'm going to start stirring with this fancy stirring stick called a straw. And then we'll record the temperature, which the temperature has actually dropped a little bit, but that's okay. Keep it at the original numbers before. Let's get pouring and see what happens. So I'm pouring the ammonium chloride into the barium hydroxide. Hopefully nothing goes wrong. There we go. So I'm going to put it back on here for the time being. So that way I can start stirring away because the reaction is currently happening. And let's get a stirring party going. Woo, woo, there we go. Stirring in the barium hydroxide and the ammonium chloride. Now, what I will say is this odor is very, oh my goodness, that is very, very strong. The smell of ammonium coming out of that. Keep in mind about your different signs of a chemical reaction. And I'll also say, just by doing this, the temperature I can even feel is getting very, very cold. Now, remember in chemistry, we have learned that if something is getting very, very cold, that means it is needing or releasing a lot of the energy that is within it. If it's getting hotter, it requires more energy. So let's see what the temperature is real quick to see whether we're gaining or losing energy. Ooh, yes, the energy. I'm actually going to put it right there. It looks like the energy or the temperature is starting to decrease very, very heavily. I'm going to wait until it stagnates and goes down to about until it stops moving so much. Make your predictions now about what you guys think it's going to be, as it's still decreasing. It's still decreasing, and it's starting to get very, very hard, and it looks very different than what it did at one time. My goodness, this is a lot. Turning into ice at this point. All right, we're going to stop it about there, and I'm going to hold the temperature probe back up and hope that I can get it into picture. Yeah, that is not joking. The temperature is about negative 4.0 degrees Celsius. You'll have to convert it to Fahrenheit on your own, but at the time that I put it in there, it was about negative 4 degrees Celsius, y'all. That is a very, very large temperature change within time. And even as I'm stirring the temperature probe a little bit more, it's starting to decrease a little bit because, again, I'm adding energy to it. It's about -5 and turning into ice. To show you what that looks like now, just in case you're curious, the powder that was there has now turned into a bit of a liquid and turned into just a white, very, very cold substance, something you definitely don't want to have, especially whenever you're outside. Otherwise, y'all, write down your predictions or write down your observations for this one, and we're about to move into Act 3. All right, number 3. We are on our sodium chloride solution in silver nitrate. Again, this here is just regular sodium chloride, and if you remember stuff from chemistry, this here is just normal table salt. We did add it in water, though, to go ahead and dilute it, so that way it can be in the correct form for us. We also have a bottle here called silver nitrate. Here's the bottle of it. I'm wearing gloves because this can really, really stain your gloves. And this here is at a 0.1 molarity. We'll learn soon what molarity means, but for our case, molarity is telling how strong this chemical is. So what we're going to do first is using this thing here called a pipette, which helps to transfer liquids from one area to another. We're going to take our diluted or our aqueous sodium chloride inside of our pipette, squeeze it in. And then here in this first slot right here, we're going to put 15 drops. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and trick shot 15. There we go. I'm also going to put some in this one here as well. That's about 15. So that way we can do that reaction one more time afterwards. Now we're going to take about 1 or 2 drops here of our silver nitrate and put it into both locations as well. Something to note, we're mixing a solid or a solid material with a liquid material. Let's see what happens and see what sign of a chemical reaction occurs for this. So I'm going to put this here. I wish there was a way I could zoom in, but unfortunately it doesn't look like it. I'm going to squeeze this glass pipette, and let's put a couple drops here within our sodium chloride and see what happens. You might be able to see almost instantly that now this chemical is much, much water. And you could even see here, it's kind of hard to see within the webcam I have here, but there is a little bit of white precipitant forming. You can kind of see it here now. There's certain parts of the liquid that's a little bit more white than other parts. This here is called a precipitate. Now, because the chemicals combined together, these chemicals can no longer be a part of a reaction. So they have went through their total reaction and now are on the product side instead of the reactant. So let me add some more drops here within this chemical. Hopefully this time you can get a bit of a better image of it. I have that ready. We'll put that down, bring this up a little bit so it's easier to see. Lean it over a bit, and let's put a couple drops in. Oh, come on. There we go. And you can see some of the white starting to form here, especially towards this area here. Let's put one more in there. For the fun of it, we're going to put some here in the remaining cup as well. Maybe that will have a better view for us. Oh, absolutely. Look at that. Now it is white on white, but for the most part, you can see that the clear solution has turned into a completely different color. Write down your observations, y'all, about this, and write down what sign of a chemical change has occurred. And let's move on to our fourth, but not the least part of this lab. All right, and we're here at the last one. Now, you might not be able to see part of my head, but that doesn't matter because the main attraction is here within this container. Now, right now, my setup that I have is a bin, a clear bin so that we can see the reaction, and a graduated cylinder. Inside of it, we have a little bit of Dawn soap. Now, the Dawn soap won't be reacting with anything. Instead, it'll be used to create more of bubbles or so with the reaction that's happening. So it's not actually a part of the reaction. Instead, we have two other chemicals. We have hydrogen peroxide, something you might use on your cuts, and something called potassium iodine. Both of these here within our cups that we have here. So first things first, on the lab, it tells us to record or to, let's see, to record the initial temperature of the hydrogen peroxide. So I'm going to take my temperature probe here and put it inside of the cup. Now, as we said before, we are assuming that this here is at around room temperature. And I'll show you guys what it's about here in just a second. So let me grab the webcam. This is a bit of a tricky setup for me currently. But the current temperature that we have is about 22.8 degrees Celsius. So please be sure that you are logging that down onto your page because that might be a sign of a reaction that could be happening. Let's set you, Mr. Webcam, right back up there. It's going to take a second to readjust. There we go. Perfect. Now I can't really see. There we go. Let's bring that down. All right, that should be good. That should be good. Next thing that we need to do is we need to place about 5 milliliters of hydrogen peroxide here into the graduated cylinder. Now, in order to help us out a little bit, I went ahead and already measured the hydrogen peroxide inside this cup. So we're going to pour it directly here into our beaker, adding a little bit of liquid here into the bottom of it. Now, the next thing that we're doing is we're going to be adding a couple drops of food coloring into the graduated cylinder as well. The purpose of this, again, it's not reacting exactly to the hydrogen peroxide in there. Instead, in the lab called elephant toothpaste, it helps to create a nice color as the reaction is happening. So I'm going to add a nice drop, and I hope I don't miss. Get on my laptop. There we go. That's not bad. We'll swish it around a little bit, make a nice purple liquid so that way you guys can see the reaction pretty well, and put it back in here. Now, the main reason why I am putting it in here is with the elephant toothpaste lab that some people might have seen in elementary school, the reaction does get a little bit messy, and I don't want to mess up the things that are around us as that would cause a lot of, well, unhappy problems. So Note what all is happening as I pour the liquid, the potassium iodine here, into the container. I'm going to actually take the webcam and let's see what happens within the beaker. And don't mind that it's dark. I'm recording this and it's about 6 o'clock here at the school, so don't say we never did anything for y'all. But let's see what happens. Let's pour this directly here into the cup. And back away. And there we go. There is our chemical reaction. There's a reason why they call this elephant toothpaste. And my goodness, does it look like it's reacting? And it's hard to see, but you might be able to see some smoke or some steam coming off of it. And me putting my hand above it, I definitely feel a very, very strong heat coming out of the solution. Now, the reaction is starting to slow down a little bit. I know that someone always asks me, can I touch the bubbles? No, because it's very, very hot. However, let's go ahead and get an official temperature of this to see whether we have released or gained energy. We'll give it a second as I observe some of the color change, some of the purple and the orange that is kind of thrown in here currently. Very, very cool. I've always enjoyed doing the elephant toothpaste lab. All right, let's see what the temperature is currently before it starts to die down. And my goodness, let me move the wire. The temperature has spiked up quite a lot. It's all the way up to about 40 degrees Celsius. It still is rising, which means that the reaction here is still happening for the most part. Look at that. That's insane. I want to say that we started out about 24 and we've almost went up about 20 degrees Celsius just within the time that we've been here within this activity. Well, there we go. We know now, because the temperature has increased, that we have a chemical change. We have a reaction that's happening, and we've also released energy. That's why heat is rising, because we have released energy. Well, that's it here for the lab. I hope that you guys have enjoyed this. Please be sure that you write down the final temperature, and at the end of the lab, you guys have some post-lab questions. Please be sure that you're filling that out and that you complete everything on here, as this will be turned in for a grade in the grade book. We have not determined what section it is in, but regardless, y'all, thank you guys so much for watching. Please send me a message on Remind if you guys do have any questions or concerns. Otherwise, see you guys later. Now, how do I pause this thing?